India is the 10th most forested country on the planet. Nearly a quarter of its total landmass is covered in dense foliage. But if you want to find the absolute extremes of this ecological wealth, you have to look to the northeast corner of the subcontinent, to a plateau known as Meghalaya. The geography here acts like a massive wall. It gets dumped with over 11 meters of rainfall every single year. This image shows the western hoolock gibbon, India's only ape species. They are entirely arboreal, relying on an unbroken, completely contiguous forest canopy to swing from tree to tree. If those canopy corridors break, their populations collapse. Here you can see the hanging traps of the Nepenthes casiana, an endemic pitcher plant. The constant, heavy rain leaches most of the nitrogen and phosphorus out of the soil. To survive the severe nutrient deficit, this plant evolved specialized, enzymatically active traps to catch and eat insects instead. This perpetual moisture forces life to adapt in wildly specific ways, creating a hyper-diverse ecosystem that operates on a remarkably delicate evolutionary razor's edge. But right now, that delicate edge is breaking. Meghalaya literally translates to the abode of clouds, yet the wettest place on Earth is currently running out of water. We can track this hydrological collapse beneath the surface map. Out of the 55,000 natural springs recorded across the state, over half have either dried up completely or are experiencing a critical decline in water flow. The region is effectively plunging into seasonal drought. For the people living here, the math is brutal. Farmers see rice yields plummet by up to 60%. The remaining water is often too toxic for basic irrigation. So how does an ecosystem receiving 11 meters of rain a year trigger its own drought? And more importantly, how are local communities pulling it back from the brink? This photograph shows miners working deep inside a narrow, unregulated rat-hole coal shaft. This highly unscientific extraction method is a primary driver of the region's environmental degradation. Look at this geological cross-section. When those massive monsoon rains hit exposed coal storage and flooded abandoned shafts, the water becomes highly acidic and laden with heavy metals. This toxic runoff leaches straight down into the porous limestone, poisoning the deep aquifers and rivers below. Compounding this chemical toxicity is a sudden collapse of the region's ancient agricultural cycle. Historically, local tribes practiced a sustainable form of shifting slash-and-burn farming known as jum. They would clear a small patch, farm it briefly, and let it rest for 30 years. But massive population growth has forced communities to shrink that fallow period. When you compress a 30-year rest into just 3 years, the forest never regenerates. As this updated cross-section shows, without the deep, stabilizing root matrices of mature trees to anchor the earth, the extreme monsoon rains simply wash the exposed topsoil away entirely. What gets left behind is biologically sterile bedrock. By extracting resources and growing food without leaving time for successional regeneration, the region is literally stripping away its own physical capacity to sustain life. Long before this modern crisis, the indigenous Khasi, Jaintia, and Garo communities engineered a totally different relationship with this extreme environment. They survived not by dominating the landscape, but by integrating completely into it. This dense, pristine forest floor is part of a law Kyntang, or sacred grove. These are massive tracts of climax forest protected entirely by deep traditional laws rather than modern government fences. The local animistic belief systems dictate that these specific forests are the physical abodes of protective ancestral deities. Taking absolutely anything out of the forest, even plucking a single dead leaf, is believed to invite immediate illness or disaster upon your village. That spiritual deterrent has kept these biodiversity hotspots perfectly intact for centuries. This is a Jingkieng Jri, a functional, weight-bearing suspension bridge built completely out of living botanical material. Instead of chopping down trees for timber that would quickly rot in the humidity, locals guide the highly pliable aerial roots of the Indian rubber fig tree across deep ravines. Over decades, as these roots cross and experience friction, their outer bark abrades away. This triggers a biological process called inosculation, fusing their internal vascular tissues together into a single, massive structural mesh. A concrete bridge starts degrading the moment it's built, but because these bridges are fully alive, they actively grow thicker and stronger with every passing year, lasting upward of 5 centuries. It proves that human architecture can actively regenerate the very ecosystem it occupies. To halt the current trajectory of deforestation, Meghalaya is attempting to scale those ancient principles using modern economics, launching a massive Payment for Ecosystem Services program called Green Meghalaya Plus. This flowchart illustrates the economic flip. The state now provides direct, continuous financial compensation to rural villages that legally commit to preserving their forests for at least 30 years. They even add financial multipliers if the preserved land contains a sacred grove or an active elephant corridor, making standing trees far more lucrative than extracting the coal beneath them. This funding has driven a massive sociological shift. While property passes through the female line, women historically had limited roles in village council governance. Today, women like the one pictured here are taking charge, with over 65,000 female leaders successfully managing these local natural resource committees. Alongside the economics, the state is deploying an aggressive biotechnological defense. Scientists are using advanced micropropagation and plant tissue culture programs to mass-produce endemic orchids and highly threatened species. By cultivating these plants in highly controlled in vitro laboratories, they bypass the high infant mortality and severe inbreeding depression currently plaguing fragmented wild populations. The result is thousands of genetically robust plants ready for immediate, large-scale reintroduction into community forests. To track this vast biological inventory, researchers utilize molecular phylogenetics, specifically a technique called DNA barcoding. By analyzing standardized short genetic markers from minute tissue samples like scat or feather fragments, scientists can rapidly identify subtle, cryptic species that human eyes might miss. This establishes an indisputable baseline of data, proving whether these economic conservation programs are actually working. When you align deep, multi-generational indigenous knowledge with cutting-edge socioeconomic frameworks and molecular science, you get a scalable blueprint for the rest of the planet. Meghalaya is proving that human society doesn't have to choose between survival and extraction. We can choose to be a